or so after you turn it into pyruvic acid, if you got oxygen, you're going to go through cellular respiration. If you don't have oxygen, you're going to go to fermentation. In respiration, you're going to oxidize that pyruvic acid all the way down to carbon dioxide, which is why we breathe out carbon dioxide and breathe in oxygen. Your final electron acceptor is going to be oxygen, or some other molecule. In fermentation, maybe you don't have oxygen available, so you can't keep going through respiration, but you don't want to just die, so you go through fermentation. And so that's not going to make a lot of ATP, but it's at least going to keep that cell alive. Before you can jump into the Krebs cycle, you're going to have to go through an intermediate step. So we're going to take these 3-carbon pyruvic acid, you're going to yank a carbon off of it. So now you have 2 acetyl-CoAs, okay? You have 2 carbon molecules. And that makes 2 NADH. So this is still in the cytoplasm. And your 2 pyruvic acid are going to turn to 2 carbon dioxides. So you're just going to straight up breathe out that carbon dioxide. If you're a person, if you're a cell, you're just releasing that carbon dioxide. And you're going to have 2 acetyl-CoAs. And I am just abbreviating everything, and you're just going to have to pay attention to that. You're also going to make energy. What kind of energy are we getting out of that?
NADH.
2 NADH. And what is NADH doing? It's carrying electrons. So it's got lots of energy in it. Those electrons are carrying energy. That electrons are going to come to the electron transport chain to turn into ATP. Okay? So then the next step is the Krebs cycle. And the Krebs cycle just cycles around again and again and again and again. So you start with your acetyl-CoA. Your acetyl-CoA is going to go through the whole cycle. And because you have 2 acetyl-CoAs, it's going to come through this twice, okay? So 1 glucose molecule means 2 acetyl-CoAs, means you're going through here twice. So every time you go through, you're going to make an ADH, you're going to make an ADH, you're going to make ATP, you're going to make FADH too. So there's another thing that's carrying electrons, and you're going to make NADH. So for every 2 acetyl-CoA, you're making 6 NADH. And what is NADH doing? It's carrying electrons. It's going to carry electrons through electron transport chain to make lots of ATP. FADH2 is carrying lots of electrons. It's carrying electrons to the electron transport chain to make ATP. ATP is straight up just energy for your cell, ready to use. And all of these 3 carbons here are coming breathing out as carbon dioxide. So you don't have any carbons left at this point, okay? So you've turned it all into carbon dioxide. Your 2 acetyl-CoAs are now 4 carbon dioxides. Okay, so that's 6 carbon of sugar. That's turned into carbon dioxide and carbon dioxide. Your sugar molecule, those carbons are all carbon dioxide that you're breathing out now. But you have made 6 NADH. You've made 2 FADH2, and you've made 2 ATP. And this is happening if you're a prokaryote. You don't have any organelles where it can happen, so it's still happening in the cytoplasm. If you're a eukaryote, you're going to spend 2 ATP. You're just going to straight up burn 2 ATP to move it into the mitochondria. So this is going to happen in the mitochondria. So eukaryotes are actually going to make 2 ATP less than prokaryotes do every time they burn a molecule of glucose, because we move it into the mitochondria, okay? So is anyone at least a little bit think you know at least a little bit of what we've talked about so far? If you know at least like one detail of it, you're doing okay, okay? Because we're going to talk about this a lot. If this is just a hot mess, I'm talking in Greek, we'll work it out, okay? So we're going to keep working on this. So at this point, we've burned all our CO2, or all of our glucose into carbon dioxides, okay? So we're not using any molecules. All of our energy we're going to do in here is going to be our NADH. Okay, our NADH is carrying electrons, it's carrying energy, so they're all going to go to the electron transport chain to make a lot of energy, okay? So this ATP was substrate level phosphorylation. We're just cutting it off this stuff. This ATP was substrate level phosphorylation. But this in the electron transport chain, what kind of phosphorylation is that? It's not substrate level. Oxidative phosphorylation. So we're about to make a whole lot of ATP from NADH and FADH2 through oxidative phosphorylation, okay? And here's a hot mess that it took me like 3 years to figure out like what language my teacher was even speaking. So if this doesn't make sense to you, you're gonna be okay, okay? We're gonna do our best, we're gonna work through this. Okay, so electron transport chain is gonna happen in a membrane. If you're a prokaryote, it's gonna happen in your plasma membrane. If you're a eukaryote, it's going to happen in your mitochondrial membrane. Okay, if nothing else, if you can just remember this chart, like you can at least remember where it's happening, then you're a third of the way there, okay? Then you can figure out what's happening, you're 2/3 of the way there, and then you can figure out how much energy you're making. This really is what you need to like be able to put together, is being able to put together this stuff on this graph, okay? So here's what happens in the electron transport chain. So we're going to pass electrons through a bunch of carriers, okay? They're carrying electrons, passing it down from one to another. And every time you pass that electron down, you're going to release a little bit of that energy out of the electrons, and you're going to make a gradient. I'm not going to ask you what the electron carriers are. So here's our okay, let me talk in words, and I really like pictures more. Okay, so those carriers are going to pass electrons, just pass it from one to the next, just pass it through the electrons transport chain. As they pass it, when they pick up an electron, they pick up a little bit of energy, they push a hydrogen outside of the cell. Then they pass it to the next guy gets that electron and pushes a hydrogen outside of the cell. Pass it to the next guy, you push another hydrogen outside of the cell. So then you've got a lot of hydrogen being pumped across the membrane, so you've got a gradient, okay? Lots of hydrogen on one side, not a lot on the other side, so you've got a gradient. Cells don't like gradients, right? They like equilibrium. So those hydrogens are going to go through ATP synthase, and when the hydrogen goes through ATP synthase, you're going to release energy and make ATP, okay? So that is oxidative phosphorylation. Passing electrons, make a gradient, hydrogen comes back in, make ATP, okay? So here's the transport chain itself. So you've got NADH carrying electrons, okay? So those electrons have energy. It passes that energy, those electrons, to the first part of it, it kicks hydrogen out. Pass them on down, kicks hydrogen out. Pass it on down, kick hydrogen out. You get lots of hydrogens, they're going to come back in. When it comes back in, it makes ATP, okay? If you understand even one word of what I just said about this, then you are doing awesome, okay? Like, this is weird to me, but this is what it's doing, okay? So what you're doing, let's talk about again what we're happening. We are passing electrons from NADH or FADH2. Okay, they're just passing down the chain. As they're passing down the chain, you're pumping hydrogens out. Which makes a gradient. Those hydrogens are going to come back in through ATP synthase. And that ATP synthase is going to take all that energy of the hydrogens coming in to make ATP. Each NADH you've made is going to give you 3 ATP. And each FADH2 is going to give you 2 ATP, okay? So it's got a 2 in it, it's making 2 ATP. So 2 ATP per FADH2. okay? So if everything I just said doesn't make sense, at least see if you can just remember the bare facts about it, okay? So this is oxidative phosphorylation. You're just passing electrons, making a gradient, ATP synthase makes ATP, okay? 3 ATP per NADH, 2 ATP per NADH2. Let's see. So, in summary, what we made, so we made glucose, we took oxygen and lots of ADP. Your glucose turned into 6 carbon dioxides. Your oxygen picked up protons, turned into water. And your ADP, you got 38 ADP, okay? So that's 38 ADP in a prokaryote. And a eukaryote is going to be 36 because you burned 2 to move into the mitochondria, okay? So 38 if you're a bacteria, 36 if you're a eukaryote. You're burning the ATP to move to move into the mitochondria. So if you added it up, you say 2 ATP. Each of these are going to give you 3, so that's another 6 ATP. That's going to give you another 6 ATP. That gives you 6 times 2, or 6 times 3, that's another 18 ATP. That's 4 ATP and 2 ATP, so that altogether should come up to 38. I'm not adding this time, but no, it should come up to 38.